Hi everyone, this is Chandan and you're watching the Learning Field. So this video is regarding the a very important update from CSIR NET. So those who are preparing for the CSIR NET must watch this video and share this video with your friends. Those who are preparing for CSIR NET, because there is an update comes from CSIR regarding the syllabus of upcoming exams. So there may be some questions that what happened to the next exams, the previous syllabus or the next syllabus. So this is not clear till now, but I'll going to explain the things that regarding this notice. So see, there is a notice that comes in 13th April 2026 regarding the consultation from the stakeholder on the proposed revised syllabus on the four disciplines of CSIR NET examination. Fine. It says that the joint CSIR NET conducted by NDA on CBT mode, the examination is generally held twice a year, 5 subjects. Considering the significant development in various subjects areas over the past decades, the need for an update was identified by the respective experts. Subsequently, the syllabus of the following four subjects has been revised by the committee members following multiple discussions and meetings held on the subject matter. And okay, so there are the four syllabuses. So we will going to discuss the case for mathematical science. So if you click here, so if you just open the CSIR DG official website, then you got the one like notice regarding this upgradation of syllabus. And if you click in this link, then you will get the mathematical science or each subject wise syllabus. In this link, chemical science; in this link, earth, atmospheric, ocean and planetary science; in this, physical science. So the revised syllabus is uploaded on the CSIR HRDG website. The stakeholders are requested to fill the feedback form given. This the link will be live from 13 April to 14 May. So stakeholder means you can also give the your feedback in this link. And more than the feedback of the same person will not be entertained. So just you will give to one feedback in each case. So now the case is you may have some different questions regarding this exam. Fine. First the questions may occur in your mind is that what will be the June 2026 exam? So will it in new syllabus or old syllabus? New syllabus or old syllabus? Fine. This is one question. Question number one. Question number two is how much change? How much change in syllabus? These types of questions may come in your mind. Okay. So let's discuss the thing, which is that first of all, the important thing is the new syllabus. See, here the date is from 13th April to 14 May. You have the time for feedback. So there need it is an government institution, and there may take time from 1 month, 2 months to 6 months, may definitely. So the case is that whether it will applicable from June 2026 or June or December. This is the main question. December. So देखो, there is no possibility to apply the new syllabus in June. First question, because it already the feedback window is already open up to the 14th May, and exam most probably the next exam most probably in June, either most probably or July. So in that case, the new syllabus is not applied for the uh, next exam. Now, it may applicable from December 2026, but there is also a big question. I think from 2027 exam, from 2027, the new syllabus may applied for the exam. Most probably from December, otherwise the next June 2027. So you means what I'm going to saying that you don't take any pressure or any tension that your syllabus will change for the upcoming exam. That those who are preparing for the upcoming exam, so you just continue your preparation. There will be no change You don't need to change your preparation strategy, or like don't need to think about the your upcoming exams. Okay, first of all, this should be clear in your mind. So how much change in the syllabus? Now if we see the syllabus, we can see that this is the proposed revised syllabus. Fine, this is the proposed revised syllabus. So analysis, in the analysis, there is sufficiently, the change is very small. So the most important change that happened in the syllabus in the uh, applied portion. Okay, in the applied portion, applied math portion. So in pure math portion, the change is very small, means next to zero, very small change. But in applied portion, in specific ODE and PDE, there is very huge change in the syllabus. Some new things are introduced. So let's see these things. See, in analysis, this is the existing syllabus and this is the proposed syllabus. You can see in detail that there is the change is very means nominal, because in real analysis the change, I think it's next to zero. I just overview this syllabus. So see, sequence series, all things are in the syllabus. So here happen, and finite countable real number system complete ordered field. So see, this term is not given, a real number system as a complete ordered field. So this is not included in the new syllabus. This portion is the new syllabus. In the RHS portion is the new syllabus. So you can see that this is not given in the new syllabus. Fine, this is not given in the new syllabus, this portion. Now Archimedean property and all the things are given, sequence series, limit, infimum, Bolzano-Weierstrass theorems, all the things are already given. New syllabus, there is no change. There is no change. Sequence series and function, there is no change. In 5 point, Riemann sums and Riemann integral, improper integral, there is no change. No change, no change. Monotonic function and all these types of problems, there is no change. Functions of several variable, no change. More specifically in real analysis, there is just changes next to means zero. Now in linear algebra, you can see the left side. Just a second. In linear algebra, vector space, all the things are same. Linear of matrices, algebra of matrices, all the things are same. Basis, dimension, transformation, there is no change. Fine, eigenvalue, eigenvector, matrix representation of linear transformation, all the things are same. Diagonalization, inner product space, Jordan canonical forms, all the things are same. There is no change. Fine. Mm, Inner product space, orthonormal, symmetric bilinear forms over R spectral theorem for normal matrices. So we already, actually there is not written in the old syllabus, but actually we read this. Fine. So there is no basically change in linear algebra also, you can say. Or you can see that matrix representation, inner product space, just a second. There is no change. Quadratic form, reduction and classification of quadratic forms, there is no change. Okay. So quadratic form in the new syllabus is not included in the new syllabus. See, in the in the old syllabus, inner product spaces, orthonormal spaces, quadratic form is included. So it is now not in the syllabus. Reduction and classification in the form. And instead of that, the spectral theorem for normal matrices included. So this is new. This is new. Fine. This was not included in the previous syllabus. So a little bit change, not an issue. Now in complex analysis, algebra of complex analysis, this same analytic functions, all the things, Cauchy, Liouville, no change. There is no change. Fine. There is no change. Okay, one thing is that this conformal mapping is not now in the syllabus. See, here the new syllabus in Mobius, up to Mobius transformation. But if you read the Mobius transformation, you must read the conformal mappings. So there is not two good things in the conformal mapping. So, but change is change. What you can say about this? Now in algebra portion, permutation, combination, and combinators, combinations, combinatorics, combinations all already that same syllabus, groups and all the things are same. Group, subgroup, fundamental theorem, all the things are same. I think basis, yeah, polynomial, yeah, all the things are basically same. There is no change. Now comes the ordinary differential equation. Fine, there is change. See here in the ordinary differential equation, this is the old syllabus. So they starts from existence and uniqueness of solutions of initial value problem, first order ordinary differential equation, singular solution, first order ODEs, system of ODEs, general theory of homogeneous, non-homogeneous, linear ODE, variation of parameters, Sturm-Liouville boundary problem, Green's function. But now see the syllabus of ordinary differential equation, and I think this is very good thing, because I always think that applied portion is very less in the CSIR NET exam. Okay, they give more importance to the pure mathematics. Pure mathematics. As a student of applied mathematics, I think this was right. This is right decision, because you have to give the equal importance pure mathematics as well as applied mathematics. But up to now, the existing syllabus is the applied syllabus is very poor. And but one more thing is that nowadays, actually they change the syllabus now. The notice comes nowadays, that is in 13 April. But if you see the questions of recent 2-3 exams, there are such types of questions in ODE and PD. Some different type of questions you already watch in the last December 2025 exam. Okay, I already solved 2 PD questions that actually I already said that you can say my YouTube channel that I said the part C questions of PD of CSIR NET December 2025. The questions are some out of the box syllabuses. Fine. I am not, I have not seen the ordinary differential equation questions, but in PD I can say that definitely. Now comes to that portion, coming to next from after OD. See first order ordinary differential equations, then existence and uniqueness. Already you, if you if you have read the you have or start the ordinary differential equation for starting or preparing, you already read the first order ordinary differential equation. There is not an issue in first case. Then theorems for initial value problems. So this is now they give more important on these types of case. Linear ordinary differential equation that already included existing syllabus. Higher order constant coefficient, there is not an issue. And second order linear ordinary differential equation with variable coefficient already have. Now Cauchy's equation, method of Laplace transformations for solving ODEs, equations, power series, Frobenius method. These the questions like this Frobenius method, power series method, Laplace transform in ODE, in the existing syllabus, these are not, this was not included. Okay, now Sturm's oscillation and separation theorem. So this is already have in existing syllabus. Already questions also comes. Then Sturm-Liouville eigenvalue problems and boundary value problems and green functions. So in OD now you have to give more focus in these types of in the this portion. Fine. Now system of linear first order ordinary differential already exist in existing syllabus. Planar autonomous system of ordinary differential equation. So this is new. Planar autonomous system, this is new. So planar autonomous system means, I think in November 2020, okay, one question comes on Bendixson criteria. Bendixson criteria, I already solved this question, Bendixson criteria and Poincare-Bendixson theorem. Poincare-Bendixson theorem. These two criteria you have to give more focus. Now questions may comes from these types of question. The stability of stationary point of linear system with constant coefficient, linearized stability, Lyapunov function is in two variable. That means they want to give the more importance in the physical overview of ODE. So up to now, the questions that comes in ordinary differential equation, you just solve the questions by using known techniques. But now they introduce the stability portions, means they want to give the more importance on the means what I'm doing that the syllabus is like system of ODs, stability analysis, these types of things, and nonlinear dynamical portions most importantly. So you have to read basics of dynamical systems very carefully in these types of if these types of questions comes. Now they already introduce the power series method. Now you have to already you have to read that these types of function Laplace transform. Now they, I personally think that they like this portion, in this portion they give like syllabuses like GATE, because if you see the GATE syllabus, these types of syllabuses are already included, Laplace function and like that. But I am very happy that they gives more importance on applied portions. Okay, this is very, I'm very happy, you can say. Now if I comes to the partial differential equation, because nowadays if you just know the techniques how to solve the ordinary differential equations, you cannot answer in your syllabus in your CSIR net questions nowadays. What type of questions actually makes in the exams? Fine. And you have to read more to understand, to visualize the OD. These types of syllabus is included now. So just by knowing the ordinary techniques and like this question, you have to solve by this way. So this is not happened now, and this is right, because in the real analysis portion, in the other sections, there are different kinds of variety of questions may be included, maybe comes in the paper, may comes in the already comes in the paper, but in the nowadays they give more important to the applied sections, and it is very ये होने वाला था, मतलब अब ये होना था actually. Now if you comes to partial differential equation, then this is the old syllabus and this is the new syllabus. So you can see that something new happened. So see that Lagrange Charpit solving of first order PD, Cauchy problem of first order PD. Yeah, there is no change in the first portion. Now second order partial differential equation in two independent variable. This is included in new things. Classification already have this classification. Canonical forms, yes, already have canonical. Oh no, this canonical form is newly introduced. So now you can get the questions from the canonical form, method of separation of variable, and this is a new thing which is included. Duhamel principle. I don't know what is this actually. But if you want, you can comment me. I will make one by one videos on what is the new things that introduced in OD and PD syllabus. I already work on a OD lecture series, and this is I now make the OD lecture series based on the new upcoming syllabus. I am just preparing the slides of OD lecture series. Okay, so you can definitely comment if you want this OD lecture series based on the new syllabus. Fine, fine. Now wave equation in one space dimension, Cauchy problem, and D'Alembert's formula. Domain of independence, domain of dependence, and range of influence. This is new thing that is included in the syllabus. Now if you see this thing, already question comes in, I think 2025 or 2024 paper, one question that comes in the region wise straight line, then divide this region, this type of one question comes in PD. This question based from domain of dependence, and in 2025 also these types of questions comes, already comes, that the two questions that I solved in my YouTube channel, you can see this, you must watch the two solutions, because how actually you have to think nowadays to the questions of PDs. So this is very important. Now Laplace equation in two variable, already mean value property. This is now introduced, mean value property, maximum principle. These two things already, questions from these two things already comes in December 2025. I already solved these two questions. You must watch these two videos, part C. In part C, part C. Where I applied the maximum modulus theorem, that is maximum principle and mean value property like this, meaning means inequality type things. Now Fourier methods for Laplace, heat and wave equation. So this is all now new things that is included in the syllabus. So you have to read now how the by using the Fourier transformation, how we solve the Laplace heat and wave equation. Actually Fourier transformation को पढ़ना भी चाहिए कि what is the Fourier transformation. Fourier transformation is very important. Fourier transformation is very important. It is not just a transformation, it's an ये क्या करता है आपको पता है फूरियर ट्रांसफॉर्मेशन. फूरियर ट्रांसफॉर्मेशन एक्चुअली क्या करता है, ये सपोज एक सिग्नल से, ओके, सपोज देयर इज ए सिग्नल. नाउ दिस सिग्नल हैव मल्टीपल फ्रीक्वेंसी, okay. This signal has multiple frequency. Now if we apply the Fourier transformation, we will get the complete spectrum. So we can study each and every different frequency, means actually wave, different frequency wave. There may be sound wave, water wave, any wave, okay. Spectrum analysis. So Fourier transformation is important for spectrum analysis of any frequency of waves, okay. So I think these types of things nowadays, because I'm a researcher of this field, I applied this Fourier transformation and these things in my research problem. So I am very happy that these types of things are now included in the syllabus. Now, if you see the numerical analysis, there is also a huge change in numerical analysis system. So system of linear equations, direct method, Gaussian elimination, LU decomposition, Cholesky factorization, Gauss-Seidel and Jacobi iteration method. I already make the convergence criteria of Gauss-Seidel method, Hessian matrix, Gauss-Jacobian iteration matrix. You can watch the video, and my two videos are very. I am very happy that I got very huge response on the two videos, and their convergence. I already make the videos on these videos. You can watch my numerical analysis lecture series for NET and GATE. I already make this video because these syllabus actually that have new things that included in the syllabus. I already make the videos because these syllabus are like GATE syllabus, so they extend the syllabus, fine. And this GATE song criteria theorem. I don't listen the name of this theorem, but okay, I will be working on that. Numerical analysis, numerical solution of nonlinear equations, bisection, regular falsi, secant, Newton-Raphson, fixed point iteration, and their convergence. Full GATE syllabus, they targeted full GATE syllabus. These types of actually not included in the existing syllabus. Then interpolation, they use interpolation, Lagrange Newton interpolation, forms interpolating polynomials, error, my goodness, error in polynomial, function, numerical differentiation, error, numerical integration, trapezoidal Simpson rule, Newton's code formulas, composite rule, mathematical errors involved in the numerical integral. My goodness. The syllabus they now want to propose in case of numerical analysis, means this is a top-notch syllabus because you have to work more. Those who actually not read the numerical analysis in your masters or bachelors, they will be in trouble because this is very top level syllabus. Means the syllabus for numerical analysis is means top-notch syllabus. So if you don't know the basics, this syllabus is means from your out of the brain syllabus. These are very important. न्यूमेरिकल एनालिसिस को आपको समझना है, ठीक है. न्यूमेरिकल एनालिसिस इज नॉट लाइक दैट, एंड नाउ दे वांट टू फोकस दैट न्यूमेरिकल solution, sorry, numerical value, differential formula, differential equation, method of Euler, Rankutta, method of order 2, means full GATE syllabus. And more than GATE syllabus they introduced in numerical analysis. So numerical analysis, those who are not read till now, means in your masters or graduation, they will be in trouble because this syllabus is not a very light syllabus. This is a very hard syllabus. Fine. Then calculus of variation. In calculus of variation, variational, frictional, completeness property. Oh, I already make the videos on completeness property on CAB. You can watch my lecture series. Means I already make this video lecture series. You can get the completeness property. I already take the lecture series. And with spectral norm, supremum norm, variation of functional, Jacobi, and all the things are most probably same. Isoperimetric problem. So this is new. Isoperimetric problem was not in the syllabus, but now they introduce weak and strong maximum sufficient condition. We already read these types of problems. Transversality condition. I think okay, transversality condition is now in existing syllabus, but so you have to read more in calculus of variation also. Then linear integral equation. So this is only the linear integration existing syllabus, but see linear integral equation with first and second kind of freedom, Volterra solution of integral equation, upper level kernel, Laplace, okay. Freedom integral. So there is no change, I think, in linear integral equation or a little bit change. In classical mechanics, there is also changes very little bit. Hamiltonian generalized coordinate, Lagrange's equation, Hamiltonian canonical, Hamiltonian principle and principle of least action, Poisson bracket, two-dimensional motion of rigid bodies, theory of small oscillation. So this is a very huge syllabus. This is just the terms are one chapter. Fine. So this is the syllabuses for mathematics part. I am not going to the statistics portion. And Markov chain. This is the Markov chain syllabus. This is likely same. Birth and death process. So Poisson and birth and death process. I think this is newly introduced. And whereas the LPP syllabus. So LPP syllabus, I think, have in the syllabus. Now here is one note is that all students are expected the questions from unit 1. Student in mathematics are expected to additional questions from unit 2 and unit 3. Students with statistics are expected to answer additional questions. This is, I think, same things that is already have in our syllabus. So this is the there is huge change in the huge change where in the applied part. Applied part specifically in ODE and PD. More change in ODE. They more focus on ODE. So now you have to read the ODE PD very carefully. Means very carefully. So these are the very small discussions I think for the syllabuses. Now syllabus may be from December 2026 or from June 2027 will be applied as per my experience says that. Fine. So if you have any doubt, then definitely comment in the comment section below. Okay. And if you have any query, then you can also comment in the comment section below. I'll try to provide the answers of your queries. Okay. Thank you. Bye. Let's meet in another video, next video. Okay.